Good morning. It's Pearson, the science teacher. So, a big hand to those that tried to answer these questions that we just have here from 5054 Physics Pure. So, I'm going to concentrate much on those that were not answered or those that were answered wrongly. However, I'm still going to go through those that were answered correctly as well. So this is 5054, also known as Pure. This was 2020 paper 1, Physics. So let's go. Yeah, so to begin with, let's first collect our data. So we have from the question our mass, that's 25 kg. What else do we have? We have a horizontal force of 60 newtons. Then we have a constant frictional force. So frictional force of 20 newtons. And what we are being asked here is to calculate the acceleration. Okay. So we know that force is given by the formula mass multiplied by acceleration. All right. So just to abbreviate everything, that's where this comes from, m times a. So we can divide both sides by m in order for us to remain with a. So a is equal to f over m. So we know our force and we know our mass. So that is going to give us our acceleration. But here's the trick. We are having two forces. Our first force is 60 newtons. Okay, but we have the opposing force, the force that's opposing our 60 newton, our horizontal force there, and that force is 20. So the force that's going to be here is the difference between these two forces. So what we have is 60 minus 20. We are going to have 40 newtons. So this 40 newtons is the one we are going to put here because that's the difference between 60 and 20. So acceleration is equal to 40 newtons over 25 kg, our mass there. So this means our acceleration is going to be this goes in 41.6 times. So the units can be a newton. Yeah, actually dividing by kg, and these units can also be written just as meter per second square for acceleration. So this was number one, and this must have been B. Yeah. So this is how to go about it. Just remember the trick here. There is need of you knowing the difference because frictional force is the force that opposes the motion of any object. So the difference is what happens to be the resultant force. That happens to be the actual force that is in action. Okay, so this was supposed to be the answer. Yeah, proceeding to number 12. So number 12, we have that diagram there, and it's clear. So just to collect the data from the same diagram, I have what I'll call weight, that force, downward force there, which is 500 newtons. Then have also the exerted force. Let me just say EX force, exerted force or force applied on the object that is causing it to move that distance of 5.0 meters. That is 400 newtons. Of course, causing it to move, so that I don't mix up my data, just say 0.0 meters. Then the height happens to be 3.0 meters. So let's study that diagram properly. We can see that this 500 newtons is actually the weight. So before we go any further, I would love to remind you that weight is equal to mass times acceleration due to gravity. So yeah, so according to the question, we're asked to calculate the potential energy and the work done. So potential energy is given by the formula PE for potential energy is equal to mass times acceleration due to gravity times height. Okay, then work is also given by the same formula, if anything, but let's not say that. We can say it's equal to force times distance. There's a video where we're trying to show that work done is equal to change in kinetic energy. We also talked about we touched the aspect of work being equal to potential energy sometimes. We are not going to delve much in that, but look, force is equal to mass times acceleration, which is mass times acceleration. So this is force already. Then height is equal to distance. Yeah, so for potential energy, we're going to have potential energy is equal to, if we have this weight here, I want you to remember that weight is equal to mass times acceleration due to gravity. So for us to have this value here, it means this formula has already been followed, mass times acceleration. So where there is mass times acceleration here, we are just, the whole thing, mass and acceleration here can be replaced by the 500 Newton, because that's the weight, then multiplied by the height, and our height happens to be 3. Okay, our height happens to be 3.0 meters. So what we are going to have is 500 times 3, that's going to be 1,500. Our units are joules. So that is going to be our potential energy. Okay, let's proceed to work. Okay, so when it comes to work, we're not going to use the 500. We are going to use the exerted force, because work is a product of force and the distance moved in the direction of the exerted force. So what we mean is, if there is a box here and this guy is trying to push it, work will be the force that is applied on this object and the distance it moves from point A to point B here. So we are using the exerted force. So instead of using 500 there, that's why we have this exerted force, and we had to note that it's exerted force. So we're going to say our work will be 400 Newton multiplied by what was the distance moved by that body when pushed. That was 5. That was 5.0 meters. So our work will be this. So our work will be 2,000 Newton meter. Remember, Newton meter are collectively just joules as well. So you can use these units or the collective units. So our work is 2,000 joules. Our potential energy is 1,500 joules. So this was question, we said this was question 12. And the correct option was B. So B was the correct option there. Yes. Okay, so number 13 there. Our number 13 reads, which of the following gives the efficiency of an energy conversion? So just to go straight to our point, the correct should be neta, should be use energy output divided by the total energy input. Okay, so when you work out your data using this formula, your answer is going to be 0 point something. So to convert into percentage, that's where the multiplication of 100% comes in. So if the correct option has this, still correct. If your correct option doesn't have this, still correct. But just know that your answer will come out not in percentage form because you haven't multiplied by that yet. So if we look nicely, our answer should be C. That's the correct option. Okay, so let's proceed to number 14. Now, this number 14 you're seeing here is so involving, and I'm planning to do a video that would cover this question. That is going to look at gas laws, the Charles law, Gay-Lussac's law, and Boyle's law. But in this case, for number 14, we are using Boyle's law because we see temperature being constant there. So just to highlight what the answer should be, let's delve in it. Otherwise, we first need to have this good prerequisite knowledge of the whole video that talks about gas laws for us to have a clear understanding. Okay, so number 14 reads, a gas is trapped inside a cylinder by a movable piston. The length of the gas column is 50 centimeters and the pressure inside the cylinder is P. The piston is pushed in a distance of 30 so that the length of the gas column is now 20 centimeters. The temperature of the gas is not changing, so it's constant. What is the new pressure P of the gas? Wow. So before we go to the data, I want to introduce you to this equation that's called the general gas equation. So it's P1 V1 over T1 equated to P2 V2 and T2. So in this formula, I would love you to know that there are actually three formulae mixed here. There's the formula that happens to be Charles' law, that tells us Charles' law, this and this. So if we had to write and say V1 over T1 is equal to V2 over T2, this would be Charles' law that we are trying to describe here, because according to Charles' law, the volume is actually direct proportional to the temperature in Kelvin. Again, we have this and this here. If we had to write it, it would be P1 over T1 equated to P2 over T2. This is actually Gay-Lussac's law that we are trying to describe here. So this is Charles' law, gas law. This is Gay-Lussac's law, and what is remaining is the upper part here. You can also get the upper part here and write it here. That would be P1 V1 equated to P2 V2. This is now Boyle's law. And according to the question that we are given, because temperature is kept constant, it means this is the formula we are using. Because what is constant here, according to this question, according to this formula, what is constant here is actually volume. What is constant here is actually pressure. So these whole three combined, we have this general gas equation. So now let's collect the data. Now that we have this information, this is what I need to make a video about, because it's quite a long topic on its own. Yeah, so data, what do we have? We have L1, I'm trying to write L1 is equal to 50 centimeters. That's the length of the column, the gas column. Then we have L2 equal to 20 centimeters. Remember that to push it to 30 so that the new will now be 20. Initially it was, as you can see, refer to the question there. As you can see, it was 50 centimeters. Then it was pushed to 30, which means the difference happens to be 20 centimeters. So this is V1 and this is V2. Remember, we're talking about a cylinder. So if we wanted to calculate the volume, we know that our volume, if we are dealing with a cylinder, will be pi r squared h. But we are not given the radius. Yeah, so we are definitely not going to use this formula, but consider the length as the volumes. So if we had to get this formula, we are going to have P1 V1 is equal to P2 V2. Pressure 1, we don't know. Pressure 2, we don't know. So what do? We are going to take it the way it is. So what is our V1? So we are saying P and our V is 50 centimeters is equal to P and our V is equal to 20 centimeters. So what do we do next here? We are looking for new pressure. So our new pressure is actually this one. So divide both sides by what it's having, even this side, 20. So what are we going to have? We're going to have this gone, giving us 1. So pressure, our new pressure is going to be, how many times does 20 go into 50? That will be 2.5 Pascal. So that will be our new pressure, 2.5 Pascal. As I said earlier on, we really need to have some prerequisite knowledge about this for us to understand. I've touched this part, I've touched that part, but I'm just trying to highlight the answer. So I think the correct option, if I had to check, that should have been A. I can't really refer to the question. That's A. Yeah. So this is how to go about. So the pressure was actually 2.5 times. The pressure was actually 2.5 times. Remember, Boyle's law states that the pressure of a fixed mass of a gas is actually inversely proportional to the volume. So when the volume reduces, the pressure increases. When the volume decreases, the pressure increases, of course, and the opposite, of course. So that's about it. So for those that tried, well done. For the answers you got correctly, well done. Let's maintain the same spirit. I like saying laziness is the work of the devil. It's been Pearson, the science teacher. Thank you very much. You can post more questions. This was someone's requested work to be done by all of us. So hence I'm thanking those that to participate in any way. Otherwise, let's learn together.